Good morning. During the opening remarks, there was a reference made to tying together smart buildings with a smart city. And this became important to me in just the last couple of weeks. I'm on a working task force for climate resilience. And it was quite clear that we could design hospitals that could work for a limited amount of time in a climate or an environmental disaster. But we are in a network of social and urban matrices that we do have to get connected to the bigger picture, or these standalone public institutions wouldn't be able to stand for long. So I felt like I had to tie it into the conference theme first. I really enjoy Dr. Jones's comments, and you're going to find that, and we didn't collaborate on this, a lot of it is going to be very similar in what I'm going to present as sort of my future wishes are obviously already being done. So I'm going to talk specifically about the owner's perspective. We know the consultants and the contractors have their own reasons why they're going to use BIM. And I think now that they're getting up to speed and they're getting the tool working, as an owner, it's time for us to step up and make our needs known. Just out of curiosity, how many people here are in that role of owner? Oh, well, okay, so I'm talking to the right group. Specifically, I'm going to talk about the full life cycle of a building through design and construction and operation, and more specifically around the operational aspect of it. And I'm going to talk about how we're using BIM for asset management, and the reason we're doing that to mitigate risk and control quality. And then, as I say, I'm going to finish off with some of my future owner requirements, which may be not so much future anymore. Who are we? We're in the Lower Mainland of Metro Vancouver. We have 12 acute hospitals, an outpatient facility, 86 owned facilities, a bunch of leased facilities, 26,000 staff, and 2,900 physicians. And we're never closed. As far as a building type, I appreciate residential buildings are very demanding, but for a large institution that is open forever and has people in there with sensitive needs, it is critical. So where are we now? What we've done over the last 10 years is to prepare a few documents. Our BIM requirements overview describes the BIM scope and high-level intent. Our BIM standard requirements talks about modeling requirements, workflows, deliverables. Our BIM project execution plan talks about the who, what, when, and why. We've got data and geometry specs that control the geometry and data during design, and data and collection specs that controls the data that's being collected by the construction team. We've, I would say at this point, we probably do a couple hundred projects a year. And we've picked some large ones to really drill down a little bit in how we're using BIM. I would say at this point, the majority of all our projects, our consultants are using BIM. But that, again, that's from the perspective of the designers, consultants. As an owner, we've picked these few projects to drill down on asset management. We've picked up, we started off looking at these key assets. I mean, these are about 13 of them as a starting point. When we started getting into tracking the assets, overall, we now have probably 17,000 unique assets. And a particular, if we use one particular project, phase 1 of the Royal Columbian redevelopment, we're probably tracking 2,200 assets on that project. I want to just tie it into what that means, and that once we've got those assets tracking, we then feed it into our CCMS system, which then generates maintenance and repair work orders. And we generate about 22,000 preventative maintenance work orders in a year. And what that means is that we're now getting to a point where we've got about 76% compliance on meeting those work orders, which is a huge jump. Before, because we didn't have the information, if the electricians or plumbers were not able to get as many preventative work orders completed. So the more we can gather the information, the better they can do their job. I've got a BIM facilities management and operation vision that we're working towards. Building information modeling has the potential to advance and transform facilities maintenance and operation by providing a platform for facilities managers to retrieve, analyze, and process building information in a digitized 3D environment. So that is our goal. In preparing for this, I did look at some of the current research. There was one particular article which I'll acknowledge at the end of the presentation, but they looked at research articles, and they grouped the articles into 6 categories according to the operations and maintenance activities that were related. And so they're O&M in general, energy management, emergency management, maintenance and repair, security, and change and relocation management. So the reports are graphed here. So this is a cumulative number of reviewed BIM journal publications on each O&M activity per year. And the research was done between 2007 and 2018. And you'll notice a jump in 2010. And I have no idea what happened in 2010, and maybe some of you wiser people will advise me. But just to look at where the action is happening. So the top green line is just general facilities O&M articles. The blue line is energy management. The yellow is emergency management. The gray is maintenance and repair, or what I'm referring to as asset management. The orange is security. And at the very bottom there is a light blue line that is alterations, relocation, and move management. So let's take a little bit more in-depth look at some of these. Maintenance and repair. Some of the major developments in BIM applications in facilities maintenance and repair are around integrating and understanding the current practice of the use of BIM and typical FMO needs. BIM is a huge database that any number or any information you can put in there can be used. Now we just have to pair it up with what are my owner needs so that we can interoperate. So we'll look at information sources, data exchange, system integration and data accessibility, fault detection and diagnosis. But by providing 3D visualization based upon information in an integrated form, BIM enables facilities managers and technicians to locate building components within the building more effectively and efficiently, and reduce the effort to find the information on those components. So let's just take a little bit deeper look at some of those information sources. Historically, the sources of building information for facilities managers come from paper documents, the rolled up drawings and manuals on shelves. We then progressed to getting it on CDs. We do have a certain level of capturing them electronically, but still a lot of the information was in the head of your electrician or your plumber. And we weren't capturing it, especially if you have large amounts of facilities information. It wasn't centrally available. We do use a lot of building management systems, as we've outlined here. And now we've got to try to integrate these different building systems with BIM. The goal is to integrate them with building systems such as HVAC control systems, local weather station, building facade monitoring systems, equipment and people tracking, equipment condition and monitoring systems, fire response, and evacuation simulation. So on data accessibility, once the required information has been captured in BIM and ready to use, the next question is how to make that information available and accessible for facilities managers when needed, and how to present the information in an intuitive fashion such as maintenance personnel can easily use it. And so here's a couple examples: the use of barcodes, RFID, and augmented reality. We're currently using and testing a Matterport for the point cloud scan type of use for an existing situation, or as a project's being built to just capture some of the things that might be hidden after construction. So barcodes and RFID tags serve as identifiers of building components, and then allow access to the relevant information linked with the corresponding objects in the BIM database. By scanning the barcode or RFID tag of the item, the mobile device will present the corresponding 3D BIM component and its information with things like instruction manuals, photos, videos of operation maintenance history, and manufacturing information. Fault detection and diagnosis. In addition to providing the information, BIM-based O&M systems also can analyze maintenance and repair tasks, such as equipment fault and detection diagnosis. Maintenance and repair procedures can be improved by leveraging BIM's visualization and analysis capabilities to detect and locate system faults and identify cause-effect patterns. BIM can be the data source for anything that can be numerically or graphically analyzed. We've got to remember this is just a big database. And as owners, we've got to figure out what is it that we want to draw out of there. We can ask for a lot of data and we'll have to pay for that to be gathered, but we got to make sure that we know exactly what we're going to use it for. As an owner, we have to identify what information we want at a very early stage, like that at the RFP stage with consultants. It's not fair for us to try to figure it out once the wheels are rolling on a project. We really got to be ahead of the game, be clear about what we want so that the team can support us. Emergency management. In a hospital, of course, this is a core function. But anyone who has facilities in an active seismic zone or an area prone to forest fires or floods, you should be really keenly aware of how you might be able to leverage BIM in an emergency situation. Current research on BIM applications in emergency management focuses on emergency evacuation planning and wayfinding, indoor localization of in our case, patients or staff or first responders, fire emergency simulation and analysis, and facility safety management. Pathfinding. Wayfinding, which is a little different than pathfinding, is a critical day-to-day function in a complex built environment. And BIM really helps us develop good wayfinding through digital walkthroughs of a project. But pathfinding in the context of an emergency is much more demanding. During an emergency, the evacuees need to be directed to safe locations while avoiding potentially dangerous areas. The first responders need to find the trapped evacuees and as soon as possible while ensuring their own safety. Moreover, the shortest path is not necessarily the safest path in many cases. Determining the optimal path and providing guidance to evacuees and the first responders require not only a comprehensive building information and real-time situation awareness, but also intelligent algorithms that can analyze the situation and support decision-making. By providing both accurate 3D geometry, semantic information on a building, BIM can serve as a data source, the user interface, and the analysis platform for pathfinding and evacuation guidance during an emergency. A little bit further along that same vein, indoor localization. During an emergency, the real-time location of first responders and occupants are critical for improving the rescue efficiency and reducing fatalities and injuries. This is a high priority for a hospital, of course, and we already are primed for expanding this knowledge. We're already tagging our patients. That could become a little bit more intelligent. And we're already using systems like WanderGuard that track the movement of certain patients. And it wouldn't be hard to include staff in all patients so that in an event that we had to evacuate a hospital, we would automatically know where everybody is. Although indoor localization is a fundamental module for many emergency evacuation and rescue systems, BIM applications in this area are scarce. Fire and life safety. The most common emergency in buildings is often fire. BIM applications in fire simulation is a compelling area because occupant behavior during a fire cannot be investigated by real-world experimentation. BIM offers a comprehensive digital environment in which all building safety-related information is available for simulations, such as fire egress simulation. BIM-based games with virtual environment have been created for evacuation training and exploring the effects of the building condition on human behavior during a fire. When BIM is integrated within the game designers are released of that time-consuming modeling task when they're creating the 3D game environment. Extracting useful information such as the location of fire extinguishers, the access control panels and information from building systems that we talked about before, or utilizing data generated by sensors can reduce the efforts of deploying these fire safety management systems. Energy management. Buildings are generally not operated very energy efficiently. They consume about 30 or 40% of the global energy annually. Hospitals are never closed. This makes them one of the most energy intensive building types. Energy management is challenging by nature because optimizing energy consumption requires an understanding of the real energy needs and adjusting the operational activities accordingly. To tackle this issue, BIM is leveraged in providing building geometry analysis during the design phase, material information, integrating and visualizing the energy-related information, assessing energy performance and simulation, and energy optimization. Systems are being developed that improve energy management by leveraging BIM-enabled platforms that facilitates acquiring, storing, and processing energy-related information, thereby providing facilities managers the capacity and capability of performing these tasks. And I won't read through the list for you. Change management. Change management, as I'm going to refer to it, is not the changes that occur during the design and construction phase of a project. I'm going to specifically talk about change management once the building is in operation. Because there's no question that class detection during design and construction can drastically reduce change orders and the subsequent impacts on budget and schedule. But once we're operating a building, change management is has to be a process of integrating a number of sources of information. We need to forecast possible changes, identify already occurring changes, planning preventable impacts, and coordinating changes across the entire project. We've come to label this as space management. As these capabilities become available, it will trigger a need for owners to have in-house BIM manipulators. It is a very unique and special skill set, and as owners, we're going to have to have somebody that knows how to manipulate this information. I had just a little scenario here. If we took a look at making a hole in an existing wall to set a doorway in it to demonstrate how the proposed approach could be applied to problem solving, engaging a bunch of different actors. So we have to include the client or the requester of the change, the architect, the electrician, the housekeeping staff, security, infection control, the doctor, the patient, the equipment planners. And then we've got to look at code and design implications. Is the wall fire rated? Are the utilities running through it? Is it load bearing? All of this information needs to be captured. And BIM is a tool that can readily do that. And I've been given the 3-minute warning. Relocation management. Relocation is critical to us because as we build a new facility, we have to train staff in their own facility, and they have to be able to hit the road running the day they move into a new facility. So we often try to do run-throughs. Security management is another huge thing, and BIM is proven to be a good source to providing the security management people the tool they need to develop their security systems. And I will, information and communications technology is huge. And as something that's happened just recently in the hospital course, cell communication is critical, and locating Wi-Fi transmitters is critical. And so I think BIM could let us analyze individual rooms and make sure that we're locating those repeat stations to ensure we've got that connectivity. There's some gaps. These gaps are obviously being met as individual standalone programs and things like that. But I think the added value of BIM is being missed. We have to look at that. Some of the challenges, interoperability between BIM and the facilities management context, and the bottom one, return on investment. This is a challenge that I constantly have. And the approach that we're taking in the public sector is it's return on risk investment. Because as a public institution, of course, I'm not making money, but I'm able to demonstrate that I can reduce risk by using these systems. I wanted to acknowledge that I got a lot of information from this particular article. And if you have questions, you can ask me if we've got 30 seconds left.
Yeah.